Hey, what's up everyone? This is your friend Sanjay here, and today we are going to understand position vectors. Already we know physical quantities exist in two different ways, different categories, scalars and vectors. Scalars are those quantities which are completely identified by their magnitude, and vectors are those physical quantities which are identified by their magnitude as well as direction. Alright, so a general representation of vector is a ray, and this point is A, this point is B. So we require two different letters to write a vector, and it is denoted as AB bar or AB simple bar. Alright, so this is a normal representation of a vector. Vector has got multiple types. All the types of vectors are very easy. The most complicated one is position vector, which I am going to explain you now. What are position vectors? So position vector, in short, PV. What are position vector? Position vectors is a vector which is assigned to a simple point. So if any point has to be converted into a vector, that vector is the position vector of that point. So for instance, if I have a point P, if I have to convert this point into a vector form, I simply write the position vector of point P is OP. So OP is the position vector of point P. So what I have done, I have assigned a vector to a point, right? Now let me explain you how I have assigned a vector to a point. To understand that, I will represent this point P in some coordinate axis system. So this is a coordinate axis system that I have taken for reference, and this is point O, the origin. Now this coordinate system can be anywhere. I mean, it is as per your choice, you can take it anywhere. Now for this coordinate system, if I am trying to connect point O with P, definitely it is giving me a vector, and that vector is OP. So vector OP is position vector of point P. Alright, suppose if I have any other point, say R. So for this point R, I am not going to have any other coordinate system. I have to use the same coordinate system for point R. So if I am connecting the origin with point R, I get vector OR as position vector of point R. Okay. Now if I connect R with P, and if I put an arrow at R, I get vector RP. I get vector PR. Okay, so I am redrawing this diagram. It is something like this. This is my O, this is my P, this is my R, Okay. So I have drawn this separately just to explain one more point. As per the triangle law of addition of vectors, vector OP plus vector PR gives vector OR. Therefore, vector PR becomes vector OR minus vector OP. Alright. Now just remember one thing. I have represented position vector of point P and point R as OP and OR, right? So the same can be written as small letter P and small letter R also. I mean to say, instead of OP bar, if I am writing small letter P and putting a hat on it, even this represents position vector of point P. Small r, a bar over it, also represents a position vector of point R. Okay, right? So OR is R minus O, minus OP is P minus O. So that is R minus O minus P plus O. O and O will get cancelled, and that is R minus P. Therefore, in general, I can write vector PR as vector R minus vector P, or any other vector AB can be written as vector B minus vector A. So that is the basic understanding of position vector. I can describe any vector in terms of position vector. So for vector AB, I can write it as B minus A, where B and A are the position vector of point B and point A respectively. Hope the video is clear to you. Thank you.